Hi, my name is Raj.
Hi, my name is Ashwin.
And I'm Jin.
And we're Team Raj. And today we're studying anti-differentiation and indefinite intervals. But before we get into new information, let's go and review derivatives and what they actually mean. So first, we see this function f of x equals x squared, and obviously if we use power rule, we bring the 2 down, and the 2 becomes a 1, so therefore x prime equals 2x. With our second example, g of x equals 10x to the 10th plus 4x cubed, we just use power rule again, and we get 100x to the 9th plus 12x squared. And with some more derivative examples, let's see that we see this another function f of x equals x cubed. The derivative, as seen before, is f prime of x equals 3x squared. However, if we add a constant 10 with g of x equals x cubed plus 10, we get the same derivative, which is 3x squared. So what this overall shows is that when considering constants that are added, which therefore includes no variable, constants become negligible when it comes to the derivative. And now we see f of x and g of x. G of x is translated 10 units up compared to f of x. However, the derivatives stay the same at each x value. As shown here, at x equals 0, the values are the same, with at x equals 0 both derivatives being 0. At negative 1, both derivatives are 3.
So essentially the antiderivative of a function is what function do you take the derivative of to get to the original one. And don't forget that you always need a constant c, and c is your best friend.
And so here we have the basic integration rule. First we have the zero rule, which is any value given will integrate to c.
And here is the second rule. So if you take the integral of any constant, let's say like 3 or 7, then the integral goes to 3x plus c or 7x plus c, or in this case k.
The third rule we have is the scalar multiple rule. In this situation, like the derivative rule, when integrating, you can take out the constant to make the function easier to integrate. Therefore, when taking the k out of the equation, we can make the derivative k the integral of f of x dx.
Next, we have the sum and subtract rule, which basically is you can split up the integrals between the sums of two functions and just either subtract or sum it up.
And finally, we have the integration of some x to the n. And essentially to do this, just like the opposite of derivatives, we'd say x to the n plus 1 over n plus 1 plus c. Because if you were to take the derivative of this second equation, then the n plus 1 would come down and cancel, leaving just x to the n.
And it's important to remember here that n cannot equal negative 1 because of how the function is represented. When seen here, when n equals negative 1, there's different integral rules that apply. But calculus isn't fun without trig. So pretty much as we see that all the differentiation rules come in the exact opposite form in the integration rules. With the derivative of sine x equals cosine x, therefore the integration of cosine x dx would equal sine x plus c. Same thing with when you derive cosine x or differentiate cosine x, you get negative sine x. And therefore the integral of sine x dx equals negative cosine x plus c. With the integral of secant x squared x dx, you get tan x plus c. The integral of secant x tan x dx, you can get secant x plus c. The integral of cosecant x dx equals negative cotangent x plus c. And the integral of cosecant x cotangent x dx equals negative cosine x plus c. In these problems, remember that the negative is extremely crucial. An easy way to remember this is that every time the answer starts with a c, with negative cosine x, negative cotangent x, or negative cosecant x, all of them have negatives. Just an interesting tactic to remember the negative in all of these integration rules.
For example, we have the function f of x equals x squared. So in order to find the integral of x squared, we need to have something to the x cubed. And so we have the 1/3 x cubed to plus c.
Okay, so here a second example is g of x equals 7x to the 6th. And the answer has to be something to the 7th, so we have to go to the 7th and divide by 7, just leaving x to the 7th. But wait, that's not all, because you also need the plus c, because the plus c is very important, and this is often the deciding point on an AP test.
But with integrals, there is a specific form that you must follow. For example, when you see f of x equals the integration of f of x dx, with f of x being the antiderivative, the little sign in between is the integration sign, almost like a weird s. And therefore the f of x inside is the integrand, and don't forget the dx that follows. And with a form like this, x would represent the variable of integration, like in this example right here.
And here we have the problem, the integral of 200x squared dx. And by using the scalar multiple rule, we can take out the constant 200 of the integral of x squared dx. And by solving it, we get 200 times 1/3 of x cubed plus c.
Okay, so here we have a combination of the sum rule and the trig rules. So you break it up, the sine x and the 3x, and you integrate each thing individually. So sine goes to negative cosine x, and then the 3x goes to 3 over 2x squared plus c.
But now we have a complicated problem with the integration of cosine x over sine squared x dx. Here, you need to be smart enough to be able to separate them into not simply cosine x and sine squared x, but cosine x over sine x dx and 1 over sine x dx. What we see here is that when cosine x over sine x equals cotangent x dx, we see a similar trend with cotangent x and cosecant x. So therefore, when we integrate them together, we get negative cosecant x plus c.
And here are the practice problems.
Commercial break.
I don't get it.
Are you tired of struggling with difficult problems?
Yeah.
Do you just want to get rid of it and then just go along with your life?
Yeah.
Well, don't wait. We have a new product called Shemakly.
How does it work?
It'll just get rid of your work.
Oh.
As simple as it. Shemakly works on different subjects, such as biology.
Whoa, Shemakly. Oh yeah.
And chemistry.
Whoa, Shemakly. Oh no.
And if you order in the next 30 seconds and buy one for the price of 5, you get 4 free.
Here are the answers. Did you get them right? Make sure you have the constant c for each of the answers.
But the one thing to recognize is that not all problems have a plus c at the end. For example, in this, we're given the initial condition that f of 0 equals 10. Hence, when we take the integral, we get x squared plus c. But when x is 0, the function f of x is 10. So we plug in the value x for 0 and we solve for c, getting x squared plus 10.
But Ms. Kardakli, what's the point of integration? Well, let's see some application.
So in review, if you derive the position, you get velocity. And if you derive the velocity, you get acceleration. So in opposite, if you integrate the acceleration, you get velocity. And if you integrate the velocity, you get position. And these problems are often come out in AP problems.
Alright, so now time for some physics. So we're trying to find the position function given a of t equals x squared. So hence, when we take the integral of acceleration, we get 1/3 x cubed plus c. This is a velocity, and now we want to solve for the position, and the position of the integral of velocity. So taking the integral again, we get 1/12 x to the 4th plus c. 1 plus x plus c2.
Now let's combine the two things we just learned. With physics with initial conditions. So now if we if we integrate AFT, we get the velocity. So with the function AFT equals 4t plus 4, if we integrate that, we get 2t squared plus 4t plus c. Then we use what the initial condition given to us with v of 0 equals 0, and we find that when you plug in 0, that both t become 0, and therefore the first c is 0. Therefore v of t equals 2t squared plus 4t. Then if we integrate velocity, we get position, if you remember. And now since we know the velocity function, we can find position. So now when we integrate that, we get 2/3 t cubed plus 2t squared plus c2. And now if we use the initial condition 0, 12, which remember to keep in mind is different from the velocity initial condition, we plug in 0, the t's cancel out again, but this time the c equals 12. Therefore the final answer becomes 2/3 t cubed plus 2t squared plus 12.
Okay, so here's an example problem. It says find the position at time t equals 3 given that the acceleration function a of t equals t squared, and you're given the initial conditions v naught equals 2 and s naught equals 7.
So the problem we see is that first, to get velocity, obviously we have to integrate acceleration. And with the acceleration being t squared, the velocity will be 1/3 t squared plus c. So therefore we use the initial condition v of 0 equals 2 and find out that when we plug in v of 0, the t term becomes 0, therefore c equals 2, therefore the velocity is 1/3 t squared plus 2. Now using that, we know that if we want to find position, we just need to integrate velocity. So we integrate 1/3 t squared plus 2 dt and get the position. So that becomes 1/12 t to the 4th plus 2t plus c. Make sure when you're writing this out that you include the parentheses around the velocity because the form wouldn't be right without it. Then we use s of 0 equals 7 to find s of t equals 1/12 t to the 4th plus 2t plus 7. However, read the problem. We are not done because it tells us to find the position at a specific time, which is t equals 3. So when we plug in s of 3, we get 81/12 plus 6 plus 7, which ends up being 19.75.
So to recap, the essential idea of this whole video was to be about integrals, which is anti-differentiation. And we covered indefinite integrals. Indefinite integrals have a plus c at the end, unless you're given the initial condition.
So something to keep in mind with all these anti-differentiation and indefinite integral problems is that you have certain rules, whether there's the power rule, which is the most common that you'll see on many AP tests and many other application problems. Additionally, with other rules such as the scalar multiple rule and the constant rule. These are important to remember. And there's also the 6 most popular trig rules. You'll learn more in the future, but these are the 6 basic ones that you should know. And remember to keep in mind that a good fact to know is that if your answer ever has it starts with a c, like a cosecant or cosine within the answer of the integral, it's always going to be negative.
And finally, we have the application and integral of physics with the initial condition.